Okay, so first of all, I had to remind myself what a subset was. So I went to this book, page 14 of this book right here. And if we here, we can see it says here that A is a subset of B, right? This is A, and this is B. This is A. Actually, I can just... This is A and this is B, right? Set B. And they're saying A is a subset of B. Why? Because every element of A is also an element of B. And we can see that, right? A has 1, 2, 3. B also has 1, 2, 3. So every element of A has to be an element of set B for A to be a subset of B. Okay, that makes sense. That makes sense. And that's every element, not just some elements, but every element. Okay, that's a nice reminder. So let's go back to the question. The question was, let S be equal to 1, 2, 3, 4, 5, 6. So that's set S. And now they're asking things like, how many subsets of cardinality, how many subsets of cardinality 4 have this? So what these questions have in common is they're all asking about subsets, right? So one useful thing might be to list those subsets, right? And well, we can have a couple of subsets here. For example, we can have just a subset of element 1, or of one element, right? So 1, 2, you can have just 3, you can have just 4, or sorry, etc. You can have subsets of just 2 elements, 1, 2, right? 1, 2. You can have 1, 3. You can have 1, 4, and so on, right? But you start to notice, wait, that's actually a lot of subsets of 2 elements, because you have to list the ones that start with 1. You also have to list the ones that start with 2, like 2, 3, 2, 4, 2, 5, 2, 6. You list the ones that start with 3, 3, 4, 3, 5. And you start to wonder, wait a second, do I need all this for this question? The answer is no. You don't need all the subsets to answer this question. In fact, the question focuses on how many subsets of cardinality 4, right? That is what all the questions are about. How many subsets of cardinality 4, meaning how many subsets that have 4 elements inside them, etc, etc. So that's why. So you can forget about these. There's a lot of subsets, so many, but they're good practice, but they're kind of a waste of time for this particular question. So I'm gonna leave them there. I might erase them later. Okay, so we're focused on subsets of cardinality 4. My fans are going crazy. Give me a second. Okay, they should calm down now. Okay, subsets of cardinality 4. Right? Let me just bring set S. Actually, let me just bring set S here so we don't get confused. Right? Okay. Cardinality 4. Remember, cardinality means the number of elements. So we're looking for sets with 4 elements inside them, right? And there are actually a lot of them. Okay, let me start listing them. Let's start with 1, right? Let's start with 1, 2, right? What I mean by that is let's go 1, 2, 3, 4. 1, 2, 3, 5, etc. Okay, let's start with 1 and 2. Let's list the ones that start with 1, 2. 1, 2. Okay. Subsets 1, 2. You have 1, 2, 3, 4, right? 3, 4. Okay. You have 1, 2, 3, 5. Right? That's a different set. You have 1, 2, 3, 6. All right? 1, 2, 3, 6. Okay? That's 1, 2, 3. You also have 1, 2, 4. You can do those with 1, 2, 4. 1, 2, 4, 5, right? You can have 1, 2, 4, 5. You can have 1, 2, 4, 6, right? We haven't repeated anything yet. That's a good thing. You don't want to repeat things. So 1, 2. Are we done? No, we still have 1, 2, 5, 6, right? Okay, 1, 2, 5, 6. We have 1, 2. Okay, that's it. That's it, actually. I think we're done. Because one thing I've noticed, I don't know if this is like an actual rule, but when I use arrows, 1, 2, like this, I've noticed that if you can only go forward, right? So what do I mean by that? 1, 2, 5, 6. 1, 2, 5, 6, for example. All these are going forward. If you go backward, right? Let's say if you're like, okay, but do I have 1, 2, 5, 4, for example? 1, 2. So this is going backwards. And if you go backwards, you notice something, right? 1, 2, 5, 4 is what we're trying. You already have 1, 2, 5, 4 right here, right? Because this is not a permutation. In sets, if I have 1, 2, 4, 5, this is the same set as 1, 4, 2, 5. It's the same set as 1, 2, 5, 4. As long as they're the same elements, it's the same set. So you can't go backwards because you'll be repeating a set. That's what I've noticed from the arrows. Every time I've gone backwards, I repeat a set. So that seems to work until now. So I'll only be going forward. That's how I know I will be done, right? I'll show you what I mean. Okay, so that's the things that start with 1, 2. There are some sets. Actually, we started with 1, 2, 3. We've exhausted all the things that start with 1, 2, 3, ne. 1, 2, 3, de. Right? 1, 2, 3 is done. Even 1, 2, 4 is done. 1, 2, 5 is done. 1, 2, 5, 6. I think we're done. We're done with 1, 2. If it starts with 1, 2, we've finished. Now next, let's go to 1, 3. Oh, sorry, I actually erased the 2 by mistake. Let's go to 1, 3. These dots just help me to know what I'm starting with, right? Okay, so 1, 3. Okay, all right, 1, 3. Well, obviously 1, 3, 4, 5 would be something obvious. 1, 3, 4, 5. 1, 3, 4, 6. 1, 3, 4, 6 is another one. And I'm done actually with 1, 3, 4. Why? Because I've exhausted all the 1, 3, 4 that are going forward. I can't go backwards because I'll be repeating. Okay, so that's 1, 3, 4. Maybe make it smaller. That's 1, 3, 4. Do we have 1, 3, 5? Yes, we do. So we can skip 4. Have 1, 3, 5 something. 1, 3, 5, 6. That's the only one actually because we've exhausted the options going forward. 1, 3, 5, 6. That's it. We're done with that. Okay, those are the ones with 1, 3. Okay, so we're finished with 1, 3. Now let's go to 1, 4. Okay, 1, 4. Actually, here there's only one. 1, 4, 5, 6. That's it. Okay, that's 1, 4. Do we have 1, 5? No, we don't, because actually if you go 1, 5, you don't have enough elements. You only have one set here. We only have 1, 5, 6, which is not, we don't have enough elements to make 4, right? So there's nothing that starts with 1, 5, because again you can't go backwards because you'll be repeating. So there's nothing that starts with 1, 5. So we're done with 1, right? If it starts with 1, we have finished all of the sets that have 4 elements that starts with 1. Okay, we're not done. Now we have to think about. Actually, I'm going to group these. I'm just going to put them here. Okay. We're done with 1. If they have 1, they're done. At the beginning, we're done. Now we have to think, okay, that's what this first dot, we've just finished the first dot. Now we have to think about, okay, what if it starts with 2? Actually, maybe I should color them. Green for start. Yeah, okay. What if it starts with 2? Okay, we can 2. 2 what? 2, 3. Let's start with 2, 3. 2, 3, 4, 5, for example, would be one of them. 2, 3, 4, 5. Right. Now, how do I know that I'm not repeating any of the sets I've already got here? Well, because this set doesn't even have 1 in it, so I know for sure that it's not even being repeated here, right? Okay, 2, 3, 4, 5 is one of them. 2, 3, 4, 6 is another one. And actually, we're done with 2, 3, 4 because we've gone forward and we've exhausted everything. Okay, 2, 3, 5. Okay, we're done with 2, 3, 4. Let's go 2, 3, 5. 2, 3, 5, 6. 2, 3, 5, 6. That's the only one because we've exhausted everything going forward, right? There's no other 2, 3, 5 something that we can have because we can't go backwards. Okay. Oh, sorry. Ooh, 2, 3, 5, 6. Yeah, and that's the other thing about the arrows. It keeps me. Okay. Have we finished with things that start with 2, 3? Yes, actually we have. We have, because now we can't have something that starts with 2, 4. No, I've just lied. We can. 2, 4. Let's go 2, 4. Okay. 2, 4, 5, 6. That's it. That's it. That's the only one we have because we have 4 elements and we've exhausted all of them going forward. Yeah. We can't have 2, 5 something, but those are just 3 elements. Okay, we're done. We're done. We're officially done with so yeah, this is actually a lot of practice. We're officially done with 2, 4. We can't have 2, 5 again because there's not enough elements. There's just 3, 2, 5, 6. That's not what we're looking for. We're looking for 4. Okay. So if it starts with 2, we finished those. And you notice that as you go forward, you have fewer and fewer sets, right? Those that start with 1, very many. Start with 2, a lot fewer than that. Why? Because remember, we can't go backwards. So if we have more numbers behind where we are starting, those are fewer sets because we can't count those. We can't go backwards. Do you know what I mean? Okay, so 2s are done. Let's see. Sets start with 3. Let's go 3. Okay. Ooh, this is. But you know that they're going to be fewer, so that's fine. 3, 4. We can start 3, 4. So 3, 4, 5, 6. Is that it? Yeah, that's done. We're done with that. So it gets easier because we can't have. Well, yeah, that's it. We only have 4 elements going forward here, and we're done. We've exhausted them. Can we have 3, 5? No, because there's not enough elements to make 4. Yeah, we're done actually, because now if you want to start from 4, you don't have enough elements in front of it. 5 enough and not enough. So we're done. We're done listing all the subsets that have 4 elements. We are done. Let me just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so those are all the 15 subsets of set S with cardinality 4, meaning they have 4 elements inside there. Yeah, there's 15 of them. Hopefully I haven't made any mistake or skipped anything. Yeah, I'm fine. Just to verify, if we started from 4, can we say 4, 5, 3, 2, 1? You know, just I'm just picking something tricky to check if my method actually works. 1, 2, 3, 4. Actually, that's too many elements. Okay, let me start that again. 4, 5. Let's say we went 4, 5, 3, 2, right? Now, what I expect is I went backwards, so I'm repeating something, right? So does the set 4, 5, 3, 2 occur anywhere? Remember, sets are not the same as permutations. So this, as long as these elements appear in some other set, it's the same set. So 4, 5, 3, 2. Let's look for that. 4, 5, 3, 2. 4, 5. Actually, let me be. Oh, we do have it here already. Boom. 4, 5, 3, 2. Yeah, we've already done that set. Okay, so I think this method works. The one of not going backwards. All right. So these are the subsets of set S with cardinality 4. So now you can start to answer the questions, right? For example, question A says, hey, how many of those sets, these subsets that we've just listed, how many of them have, what was the wording? Okay, well, first of all, how many are there of cardinality 4? Okay, cardinality 4. I apologize for my handwriting. Actually, I can't stand it. So let's see. Cardinality 4. Okay, so meaning how many of these subsets have 4 elements? The answer is all of them, because that's what we were focusing on in the first place. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Cardinality 4, the answer is 15 subsets. Okay. Yeah, that's okay. B. How many subsets of cardinality 4 have 2, 3, 5 as a subset? Okay. So what they're asking is, of all these subsets that you've just listed, how many of them have 2, 3, and 5 inside them, right? So let's see, 2, 3, 5. Yep. We have here 1, 2, 3, 5. What else? 2, 3, and 5. 2, 3, and 5. We have here 2, 3, and 5. Yep. 2, 3, 5. We have here again. Yep. Looks like there's only 3, so the answer here would be 3 subsets. Okay, part C. Part C. Part C. How many subsets of cardinality 4 contain at least one odd number? Okay, at least one odd number. At least means one odd number is the lowest that you can go, right? At least. It's the lowest that you can. So you can have one odd number, or you could have more. One odd number or more, right? How many of the sets have one odd number or more than one odd number? So you can just shortcut, right? If it has one odd number, it counts, right? If it has one odd number, well, that's an answer. So we have, okay, 1, 2 could have 1. I don't even have to worry about 3. I know it's an odd number, but at least 1, okay. 1, 2, 3, everything with 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 here. Oh, there's 3 here. We have 11, 3 here, 12, 3 here, 13, 5 here, 14, 5 here, 15. So all of them have at least one odd number. So the answer is 15. Or it's the same. 15 subsets. Okay, part D. Oh, sorry, I have to erase these things. I should strategically okay. Oh, how do I erase that? Okay, cool. Part D. How many subsets of cardinality 4 contain exactly one even number? Okay, exactly one even number. Exactly one. Exactly, just one. Okay. Let's see. I think it would be better to just cross out the ones that don't fit that. So 2 and 4, that's more than one. 2. Okay, hey, we have a winner. So this would be 1. Let's see. 2 and 6, that's more than 1. 2 and 4, more than 1. 2, 4, 6, way more than 1. 2 and 6, more than 1. 4. This is a winner. Have here. 4 and 6, more than 1. 6. Oh, we have another winner here. 4 and 6, more than 1. Even number. 2 and 4, more than 1. 2, 4, 6, way more than 1. 2 and 6, more than 1. 2, 4, 6, way more than 1. 4 and 6, way more than 1. So it appears as though we have 3 subsets with exactly one even number. Okay, so the answer is 3 subsets. And that is how I would approach this question. First, list the subsets. Not all of them, because the question focused on, all the questions focused on subsets with cardinality 4, meaning subsets of set S with only 4 elements. Okay, so yeah, that is what I would, that is how I would do this question. I might have made a mistake somewhere. You can cross-check. Maybe there's some sets I didn't catch or whatever. But yeah, that is how you'd handle that. I'm just going to erase these because I like to be smart, I guess. I don't guess, I just really do. Okay. Yep, and that's it. That is the entire question.